Okay, so far we are into the second part of the first module, which is related with self and mutual inductances, right? So the next topic in the same is coupled circuits. Okay, so what are coupled circuits? Let's try to understand with the help of a network diagram. This is V1 and V2. This inductor is L1, this is L2, and the dots, as we are studying dot convention, are placed in this way, and we have a mutual inductance between L1 and L2 designated as M. So this is called as a coupled circuit. Why? Because we have a independent inductor L1, we have an independent inductor L2, and they both are having some effect on each other. So that effect is called as mutual inductance. And this inductance is called as self-inductance L1, this is called as self-inductance L2. Now consider there is some I1 and I2 equal to 0, right? So what I am saying, when current flows, I1 flows in the first coil and I2, this is I2, this is I1, I forgot to name them. So when the current I1 flows in the first coil and I2 is 0 in the second coil, what will happen? Flux phi1 will be produced. So how will it be produced? It is, the current is flowing downwards. So my thumb points downwards, thumb in the direction of current. So curled fingers give the direction of flux. So flux is going like this, right? So what will happen? Some of this flux, as you have studied in transformer, will also get linked with this one, right? So a fraction of this flux also links with the second coil, and what will it do? By inverse of Ampere's law, as we have studied in transformer and in previous lectures, it will induce a voltage here also, right? So how will get linked? So it will get, so if it's going behind, it is going like this. So behind it is going like this, forward it is coming like this. So in the same manner it will get linked up, right? So if it is getting linked in this way, so again current is flowing downwards. So current is flowing downwards, right? Fine. And we have seen if the current here also it is entering. So here it is also it is entering. So both are positive. So that is what we understand from this, that both the polarities are positive. So before that we write the voltage V1 in the first coil. So what will be the voltage V1 in first coil? For an inductor, V is what? L di by dt. So V is L1 di by dt for I2 equal to 0. Similarly, voltage induced in the second coil will be what? It will be due to this mutual inductance. So what will it be? V2 will be M, and it is due to the first current only, remember. I2 is 0. So it is di1 by dt again at I2 equal to 0. Again, why it is I1? Because this flux is getting linked with this inductor, and this flux is due to the current I1. That's why this is I1, and this is the mutual inductance which will be given in the question. So that is why this is M and not L2 or L1. L2 will be when current I2 flows. So since current I2 is not there, there is no question of L2, right? And why this is positive? Because both the polarities are, both the dots are in entering. So that's why we have seen it is aiding each other. So plus, right? Now let's say, so we have seen I1 is flowing and I2 is 0. So now let's say I2 is flowing and I1 is 0, right? So again current I2 is flowing now. So it is like this. So I am getting in this direction. So same flux I am getting. So again it will get linked in this way. So again I am getting the same current flowing downwards, which is the case, and both are entering. So plus. So what will be V2? It will be self inductor wala voltage. So V2 is L2 di2 by dt at I1 equal to 0. Similarly, what will be the induced voltage V1? It will be M di2 by dt. Remember, again I am writing I2. I1 equal to 0. So what we say, the polarities of V1 and V2 are following dot convention. Now what will be happening if both the currents are flowing? Right? So now let's say when I1, I2 flow, by using superposition, what we can say? We can use superposition, because we know when only one source is there. When one source is there, this is the case. When only this source is there, this is the case. When I am saying only I2 is there, that is only voltage source V2 is on. When I am saying only I1 is there, voltage source V1 is on. So what will be V1? So this will be like V1 prime, this will be like V1 double prime, this will be like V2 prime, this will be like V2 double prime. So what will be V1? It will be V1 prime plus V1 double prime. What will be V2? V2 prime plus V2 double prime. Right? So what will be V1? So therefore V1 equal to V1 prime is L1 di1 by dt. So we will not write at I2 equal to 0 now, plus V1 double prime is M di2 by dt. And similarly, what is V2? M di1 by dt plus L2 di2 by dt. Right? So now you can think conceptually why I get this sort of equations. So I1 is flowing, I2 is also flowing. So V1 will be what? Obviously due to self-inductance, so that term is there. And there will be this mutual inductance occurring due to this. What will this current I2 do? It will create a flux around it. That flux will get linked with this I1. So I2 is interfering with I1. So that is why I2 terms come here. And how is it interfering? With the help of this mutual flux. Similarly, you will find when V2 is flowing, it will be due to inductor L2. So that is there. And again, mutual flux M is interfering because of this current I1. So M due to I1. Right? So next step is to write this in network form. Right? So let's try to write this in network form. So if you try to show it, it will look in this way. So this is plus, this is minus, this is V1, this is current I1, this is L1, and this should be what? M di2 by dt. Right? That is, we are drawing separate network for each. Similarly, if you draw this further, it will look like this. So this is plus minus V2, this is I2, this is L2, this is plus minus M di1 by dt. This is plus minus. So you apply KVL here. What will get? I am applying in this direction. So I am going from minus to plus. So plus V1 minus voltage across inductor is L di1 by dt, plus to minus. So minus di2 by dt equal to 0. So take this here. What will get? V1 is L di1 by dt plus M di2 by dt. So V1 is L di1 by dt plus M di2 by dt. Both are same. Right? Similarly, you apply KVL here, it will be same as these equations. V2 minus L2 di2 by dt minus M di1 by dt equal to 0. So take the two terms there, you will get the same equation as this one. Right? Now this is one of the case. But we have seen the dots can be here, the dot can be here also. So let's see that case now. Now same circuit, only the dots are placed at the opposite ends. This is V2 plus minus, this is L2, this is L1 plus minus V1, this is I1, this is I2. I had forgotten last time to name this. So this is again mutual flux M, and this is the dot, but the other dot is here. So again what will happen? This will create a flux in which direction? Like this. So it is going like this. So like this. Right? So this will get linked here in the same way. So I am getting the current in same direction, but this is what? This is exiting. So the mutual flux, what we take it as negative. We have seen in previous sums. So again you can write the directly by superposition I am writing now. So what will you get? V1 will be due to this same inductor, self-inductor, it will be L di1 by dt. And we have due to it flowing here, it is what? M di2 by dt. Right? And it is negative because they are in opposite directions. So this is negative. Similarly, what will be V2? So first it will be L2 di2 by dt. You don't have to think of self-inductance. It will always be positive. And this is again in the opposite side as compared to this. So this will be minus, and current will be what? Due to I1. Right? So M di1 by dt. Right? So again, remember here it is di1, this is di2. Why? Because v1 is having the own current, own inductor i1. So because of that, this is current i1. But this is interfering with i2, right? Or this is interfering with the inductor L2, which is having following current I2 through it, right? So that is why we have I2 here, di2 by dt, right? So this current, both the currents are interfering with each other, I1 I2, I1 I2, right? So again, let's try to represent this in terms of dependent sources. So again, I'll have almost same circuit, but I'll just change the signs. This is plus minus V2 plus minus V1. This is I1, this is I2, this is L1, this is L2. Now you will have to just change this polarity, rest all will be same. So this is M di2 by dt. This is M di1 by dt. Right? So now apply KVL here. So again take this part. So minus 2 plus, so V1 plus V1 minus L1 di1 by dt plus M di2 by dt equal to 0. So take this here. So V1 is, sorry, so V1 is L di1 by dt minus M di2 by dt. So same equation. Similarly, you apply here, you will get this equation, right? So this is the way we get the coupled circuit. So you don't have to do this in the exam, but it is very important to understand the concept. If you are just remembering this, you have to by heart it. So in the exam, if you get a numerical, what you can do, you can draw these things in your rough page, then you can derive this. Because I don't prefer by hearting, I'll always derive things. So then, if you are into by hearting things only, then you just have to remember this thing when they are opposite dots, and for same dots, you have to remember this circuit. But I will not recommend that. Okay. So like this, there will be how many cases? So I'll use a green pen, sketch pen to show that. So we have already seen two cases, right? So this is one case. This can be the second case. So first, second, and we have third case here. Fourth case can be like this. So for four cases, we have four networks. But if you just solve and derive in the way which I have shown, we'll find that there are actually four cases, but only two networks we can have. Okay. So let me draw a diagram. So this diagram is very important from final exam point of view and for your tutorials also. So let's have a coupled circuit. Then we have time domain equivalent circuit. So these are called as equivalent circuits. Then we have frequency domain equivalent circuit. Okay. So let's draw the first case. So again, same diagram. So this is I2, this is I1, this is L1, this is L2, this is plus minus V2, plus minus V1. And dots are placed in this way. Is anything missing? No. So what is the time domain equivalent circuit? We have already done it. What is it? It is this circuit, right? Why it is time dependent? Because you are getting d by dt term. So it is time domain, obviously. So we have an inductor, then we have a dependent source with plus up above and minus downwards. And this is V1, this is I1. Then we have like this. This is L2. What is this? M di1 by dt. What is this? M di2 by dt. This is L1. M is I2. So this is I2. So this is the equivalent circuit. So if we go into frequency domain, what does L1 become? You have already studied this. So this becomes L1S. So S is what? J omega. You have studied in Laplace transforms. So S is nothing but J omega. If I draw in frequency domain network, this is plus minus This is now j omega L1. So this will be what? J omega mi2. So d by dt is also j omega. So this is plus minus v1 I1 plus minus this is v2 j omega L2 j omega m I1. So this is I2, right? What is the next case? So plus minus v1 L1 I1 L2 I2 plus minus v2. This is 2, right? And now are the dots placed? Now they are placed over here, right? So again the flux will be in the same direction, here also same direction, and both are exiting. So what will be the thing? So if you derive this, you can derive it at your convenience. So you'll get the same circuit, exact same circuit. Okay, so I'm not drawing it. So what is the third and fourth case? So again for third and fourth case we'll have the same circuit. So I'll first draw both the circuits here. This is plus minus v2 plus minus v1 I1 I2. This is L2. This is L1. What else? This is M, right? And dots are placed like this, right? So what is the time domain equivalent circuit? We have the inductor, then we have dependent sources. And what is the difference with as compared to previous one? We have the polarities in the opposite direction for dependent source. So this is V2, this is V1, this is I1, this is I2, this is minus plus, this is minus plus L1, L2. What is this? M di1 by dt. What is this? M di2 by dt. What becomes in frequency domain? So exact same circuit will draw, just the notations will be changing. Minus plus minus plus. This will be j omega L1, this will be j omega L2, this will be j omega m I1, j omega m I2. This is I1, this is I2, this is plus minus V2 plus minus V1, right? And what is the final case? So I1, I2, this is the mutual flux, this is V2, this is V1, this is L1, this is L2. And how are the dots placed now? Like this. So again, if you derive this in the previous case I explained, we'll get the same network. Okay. So these are what? Coupled. These are called as coupled circuits. Okay. So the next lecture will solve. So there are two types of sums to based asked on this. So first type is they'll give any network and they'll ask write mesh equations or KVL equations, one and the same thing, for the network shown. So this is the first case. And what is the second case? It will be somewhat like this. In the network shown, find V1 and V2, or it can be find I1 and I2. And in your syllabus it is only for mesh analysis. So if you are referring any book, make sure you study sums on mesh analysis only, and you have maximum 2 loops. So there won't be any question in the exam which will have 3 loops. So you won't have to apply mesh analysis using 3 loops. So we'll have only mesh analysis, no node analysis, no nodes, only 2 loops questions on. And okay, so we'll solve this first type sum tomorrow and the second type day after.